All right, we're going to look at this competitive rowers problem here. So they're trying to distinguish between novice and skilled rowers, and they focus specifically on the angular velocity of the knee. So they selected two randomly selected groups of female competitive rowers, a group of skilled and a group of novices. So we got two groups here. They mentioned the angular velocity is what they're looking at, and then data below is taken from two normally distributed samples. That's important to note here. So then we've got skilled, we got their sample size, we got their mean, and we got their standard deviation. For novice, we've got the same. Now, they say researchers believe that knee velocity would be higher for skilled rowers. Let's see if the data provides convincing evidence to support that belief. All right, so what are we comparing here? We're looking at the angular velocity. So I'm going to establish my null here because we're looking at evidence. If you're looking to put together evidence and statistics, that leads you to believe you're doing a hypothesis test. So I'm going to do that. We're looking at the average. Now I'll do of S, which would be average skill, and let's see, angular velocity. And then I'm going to establish one for the novice, which is mu of n, average novice angular velocity. Same thing. Excuse my writing. All right, so we're going to shrink this down. So we have this off this side. We know what our variables are. All right, so your null, remember, null is dull. We're looking at something pretty basic here. It's always equals. So I'm going to establish mine as mu of s equals mu of n. Or, some people like to set it up this way. If they're the same, when you subtract these values, you should be getting 0. Now remember, we're not theorizing specifically what these values are. We're just theorizing that there's no difference. Now our alternate here, we're trying to prove that the skilled rowers have a higher velocity. So that would be mu of s will be greater than mu of n. The skilled rowers are going to have a higher velocity than n. Likewise, if you wanted to set it up like this, you could do, mu of s minus mu of n. If the skilled rowers have a higher velocity than the novice rowers, when you subtract those two values, you should be getting something greater than 0. So you can go with either of those for your null and your alternate here. So you'll notice I got two choices. All right, now the next step, I have to check my conditions. Let's see, we want to check let's go with random first. Is it random? Let's check up here. They tell me two randomly selected groups. I'm in pretty good shape here. Now I want to make sure that my sample size is greater than 30 or it's coming from a normal population. They're telling me my samples are normally distributed. They give me that. That's awesome. That means my samples are normally distributed, which means my populations are going to be normally distributed. I got both of those done. That's awesome. The only thing I really have to check now is my 10% condition. So for 10%, let's see. Does 10 represent less than 10% of skilled rowers? I think it's safe to say that is true. Let's see. What about 8? Is 8 less than 10% of novice rowers? I think it's safe to say that that's true. So I have met my 10% condition as well. Notice that I didn't just merely put check marks. I went to the quotes here, I highlighted them and I put check marks. Always identify that. You want to make sure that it's not just a matter of doing check marks. You want to make sure that you're identifying specifically those conditions. So now I'm at the point where I want to run my hypothesis test. So, whoops, I didn't want to do that. I'm going to pull up my calculator. And I'm going to go to stat, and I want to run myself a 2-sample t-test here. I got 2 samples. And I don't have to enter in data. They give me my statistics here, which is pretty cool. I've got my first average is 10. I'm going to plug that in. Let's see, I'm up here. Let's try that again. Data. Nope. All right, 1, 0. All right, having some technical difficulties. Let's try that again. Oh, all right. Get rid of that. We'll try again. Now I'll have to do this using my calculator. All right, let's try that again. I love technology, guys. Patience is certainly appreciated right now. All right, so this is working. All right, I'm going to go to Sample t-test. See, can I use my arrows? I can. All right, so I'm not using my data. Okay, I'm going to enter in. Why is that not working? Input 1, 0. All right. You know what? We're going to do this the second way here. Bear with me. Since this isn't working, we're going to... Oh, let's try now. Nope. We'll have to embrace that at some point. Here's what I'm going to do, though. I got Notability open. I'm going to use my calculator, and I'll kind of do a picture here so you guys can see what I'm entering in. All right, 2 sample t-test. So I'm going to go and enter in my statistics. I've got 10 for my mean. No, I've got 10 for my sample size. Excuse me, I got 4.18 for my mean. That's why it's always good to read these things. My standard deviation is 0.479, and my sample size is 10. For my second one here, I'm going to go with my average being 3.010, standard deviation of 0.339, sample size of, come on. Again, these things happen. Size of 8. All right. And I'm going to show you exactly what I typed in, and maybe that'll help you guys out a little bit. Again, apologize. Apparently my calculator function is not working on my iPad, so you may do with what you have, right? All right, here we go. So I'm going to go with the camera function, so you'll have to see it. Here we go. All right, you'll notice I entered in my mean, my standard deviation, my sample size. Mean, standard deviation, sample size. And now I'm trying to prove that mu1 is greater than my second mu here. So you'll notice that I have mu1 is greater than my second one. That's what I'd want to go with. So now I can just hit enter. Enter. There's my enter button. Cool. Go down. Pooled, no. And calculate. Let's see what we get. Awesome. So we get our standard deviation. We get our p-value. We get our test statistic. We are in really good shape here. So I'm just going to import this into Notability. And again, sorry for the delay, but as you guys know, sometimes technology isn't always working with us. So let's try that. Cool. All right. So I included it here. And you guys can do the same when you're doing your work. All right, so my p-value is pretty darn low. Notice it's in scientific notation. I've noticed some people giving me p-values greater than 1. That'll never happen. If you see something that's greater than 1, look over here. That tells you it's in scientific notation. So ultimately what that means is my p-value here is going to be pretty darn low. It's going to be 1, 2, 3, 4, 5 decimal places away. That's a really low p-value. I'm also going to write my t-statistic, which is 6.0678, somewhere in that ballpark. Tell me it's about 6 standard deviations away from what I'd expect. That's a really low p-value. Since I have a low p-value, I reject my null hypothesis, which means I accept my alternate. So, since my p-value is less than... Now my significance level, I'm assuming is 0.05. Unless they tell me otherwise, I reject the null. And you don't want to just leave it here. You gotta include context. I have enough evidence to prove... What am I trying to prove? That the angular velocity for skilled rowers is greater than novice. Enough evidence to prove... Angular velocity of skilled rowers is higher than novice rowers. Again, I come back to this. A lot of people call stats a math course. There's a lot of writing in here, though. It's important that you always establish a conclusion here, because it's not just about numbers. You're trying to prove something here. So let's go back here. So I established my conditions. You'll notice I have my null and my alternate here. Null's always equals, or if you subtract your 2 mu's, they're going to get 0. My ha here, I was trying to prove that one was greater than the other. So I established that one was either greater than the other. I established that one subtracting from the other is going to be greater than 0. I ran a 2-sample t-test on my calculator, and these are the values I got. And I end up with a nice little conclusion here. Hopefully this helps you with this problem, and if you have any questions, you can always email me at statsgamash@gmail.com.